Welcome back. In this lecture, we are going to discuss about conversion of Moore emission to mealy emission. Conversion of Moore emission to mealy emission. Here is the following fourth step involving to convert Moore emission to mealy emission. First step, draw the Moore emission automata. Okay, first we have to draw them given the Moore emission. Then construct the Moore emission transition table. Okay, transition table, as all of you know about the transition table, which we discussed in previous classes. Okay, then convert it into the mealy emission diagram. Okay, mealy emission, and we have to construct the mealy emission transition table. Okay, let's go through some simple example. Okay, let's go through one simple example. Okay, on taking input as 0, go to the B state, produce the output as small p. Okay, if it takes, it is a basic and simple example, friends. Okay, sorry, it's not a, it's 0. Okay, I did a mistake. It's 0 and it's 1. Now we have, it is a given Moore emission diagram. How can we say that it is a Moore emission? As I told earlier classes, the output symbol present within the state, then it is called a Moore emission. When the output symbol present within the input symbols, then it is called a mealy emission. Now we have to convert it into the mealy. It is a Moore emission. I have to convert it into the mealy. Now we have to write the transition table. Okay, for mealy emission. For this, sorry, for Moore emission. Okay, first you have to write the Moore emission diagram. Okay, transition table. First of all, state. It is a state and input. Input symbols are 0, 1. Okay, in the above diagram we have chosen only 0, 1. Then output. Okay, we have to write the transition table for it. First, starting with the start symbol A. Okay, A on takes the input 0, it will goes to the B state. A on takes the input 1, it goes to the A state only. Then produce the output A state, produce the output as B, so we have to write the output B. Now nested B. B on take the input 0, goes to B only. B on take the input 1, goes to C. Okay, then we produce the output B. The output symbol present is in the state only. Now we have to write this state. What state we have going to compare with the input? No, that state output we have to write within the same output here. Okay, now C. Sorry friends. Now C state on taking the input 0, it goes to the B. Okay, it goes to the B. C on takes the input 1 equals to A, and it produces the C produces the output as A. It is a transition function for the more emission. Now we have to convert it into meal emission. Okay, meal emission is very simple. First we have to construct a meal emission diagram while comparing with to the more emission diagram. Okay, let's draw the states as it is of the more emission. A, B state, then C state. It's clear. Now we have to add the input and output symbols. Okay, now A on takes the input 1, it goes to the same state only in more emission. Like that same manner, A on take the simple one goes to N only, but here the output function is very important. Here the output symbol must be the destination state. I mean, if the take an example, if A on takes the input 0, it will goes to the B, then we have to write the output symbol which presents with the B state. Is that clear? Don't get confused. If A takes the input when it goes to A only, then we have to write the A state output function within the input symbol. Okay, here the B, it is an output symbol, so have to write here only. Now A on taking the input 0 goes to B. Okay, A on taking 0, it goes to the B and produce the, and B had B produce the output as small b, so we have to write the B here. Okay, the output symbol must be the destination state. Okay, it is a source state, it is a destination state for an input 0. Okay, if A takes the input 0, then it starts its journey from A to B. So A is a source and B is a destination, so we have to write here the destination state of output symbol within the input symbol. Okay, so clear. Now beyond taking the 0 goes to B only in more emission, like that. Beyond taking the input symbol 0, if it goes to B only, then it produces the output as B, because B consists small b as output. Now beyond taking the 1 as input and goes to the small a. Okay, small a is her source. Okay, your source is a B and destination is a C state, so we have to write the destination part of the output symbol within the input symbol. Okay, have to write the A here. Now C on taking 0, it will goes to the B state and produce the output as small b. And C on input 1 goes to the A state and produce the output as B. So is it clear? It is the equivalent mill emission for this mode emission. Okay, now we have to construct the transition table for this mill emission. Here is the different transition table for the mealy and mode emission. Both are not similar, both are different. Okay, here the state, and it is on 0, one part of the input and another one is 1. Okay, another one is 1, then input output. Okay, input output, it is a tabular column for the meal emission. We have to write like this. Okay, state. Okay, first let's go through it. A state on taking the input 0, it will goes to the small b. Okay, 0. Here always we consider input as 0. Here always input considered as 1. Then it produce the output small b. That output we have to written here. Is that clear, friends? Now a on taking the input 1. Okay, input 1, it goes to the state a only, so write a here and produce the output as small b. Okay, now next b state takes the input as 0 and goes to b state only and produce the output as small b. Takes b on takes the input 1 and goes to the c and produce the output as small a. C on takes the input 0 and goes to the B and produce the output as small b. C on takes the input 1 and goes to the A and produce the output as B. So hence completed. It is the equivalent mealy mission for the Moore mission. It is a procedure to convert the Moore to mealy. Thank you.